We're just setting up another weapon of mass destruction. God, thanks. You join a MFC-990CW club blog, and we upload all this information onto our blog for brother users, other brothers. What do you think of that? Everyone would think we do here. We can put probably in movies up. I mean, there's all the security we're going through now, you know, I'll set it all up. It's bought and paid for, right? Amazing.
And it's working there.
Yeah. So, while we're doing that, talk a little about this.
This is the drawing that we sent down to my buddies down in Melbourne, who helped me before when we was building the big magnetic motor. So I told them we're doing this one here and it's going to be free. So I get first off, get an email saying, can you send a file? I'd already sent it. So this time I sent it again. When he gets it, we're talking over the phone today, and he says, okay, there's 5 big pieces and the little pieces. And I said, yeah. And I said, well, I'll send you another one. And I had to alter it because by a miraculous coincidence, the magnets that have arrived are 30 mil by 10 mil. Much more powerful. All right, so I said, no, there's only 4 in it. And he said, no. So he then ships me up this, and this is what he got. If you go from that point to that point, it is 313.4 millimeters. Okay, I got to reboot and make it work. But I'm in the middle of a ripping yarn here. So I then send it again. Again, I've taken this file, saved it to desktop. After I altered it, that one there, not that one, another similar to that one. Very similar. That's an earlier one. This is one that I sent to Grant. This is a very good idea, this one. If you made a big one. Whoa. Okay, so we're heading for the this one is probably the ultimate. maybe do that 3 meters across. These would be 100 mil by 20 mil, 25 mil in acrylic, maybe 1-inch acrylic. And you demonstrate over unity. Now, what I had proposed was you take from there up to there, with a tiny bleed off hole, that would run into a series of teeth designed to capture the air. Or something like that. So basically, what you want to do is and you have rows of those. Cut into the surface of the 10 mil thick plastic. Alright, so you copy that. Right down there. And the amount of air that comes out compressed by the magnets, and I'll show you that now. So this is open. A pocket. So you've got the outside of the blade there, which holds this all together, and the other side, but this has been machined up so you've got little cavities. And that under high pressure, now how the pressure is going to come about from that little hole, go to here, right, now we've got neodymium magnets, they're very, very tough. You can get them to a huge amount. So we'll just say, as it's being compressed into there, all this air that is in front of it from this point onwards It's compressing. Something like that. And it is pushing air out through there. Then you have a secondary one doing the same thing here. So there's one exhaust, just one consumes more. But behind this is 4 up to 8 compressing 1 on the other. Let's say it's designed, in this case, 3. That is going to go past there, and here is going to be repelled or attracted when it's in that position. Costs nothing. It's pulling it in. Helps you. It's a win-win. And this one comes ripping into here, attracted to it, to compress the gas here, where you could have another outlet. Straight up. This time a tiny one. But super high pressure. A bit like that. And this, of course, is compression that moves into there. This air trapped between these two exit through there. This then still pushes more air into here. After all, this is now equalised. So we've got an atmosphere compressing that again to that point, followed by finally this one here pushes it all up through there and past. So that becomes an open valve from that point there. Now, all that has to be in the actual physical design of it is a line drawn across there with a Dremel tool, any shape you like, and then you tighten it down with the acrylic, or you drill straight through into it, there and there, edgewise. You've got 6 mils to play with. So there you go. So as we begin to spin, these are alternators. And they're driven by a gearless neodymium magnet setup, like so. So that's the north and that's south, not the north and that's the south, so forth. No, wait a minute. North, south, north, south. So that's north, that's the south, that's a north, that's a south, that's a north. So it's intermeshing waves of magnetic fields. Now at that point there, you can put electrical coils of wire to pick that up interaction of those magnets. There's just turning this power here. And this power is delivered by a 25mm shaft, which is clear acrylic, on bearings that are made out of acrylic. So now I'll go show you the bearing. It's costing you $100 for each one, basically. So we make up bearings. They look like this. This is out of acrylic. Now this is the back part. You want to be able to see through there anyhow, because you want to see the workings of the magnets, and these will line up miraculously. However, when they're cut like so, you've got 6 mil and 25 mil centre, and the outside is, you want to find out that. And you can make it any size you want, but 75 mil. Here's another one here. It could be a spacer between that and that, because you want to get more length of the bearing along the pipe. Now, I should also add that along the pipe itself, now what you're going to do is put a spiral down it. This should be working. There we go. So you're going to have a spiral around it like that, which will be your channel for oil. You're going to lubricate it with something. And then as you're turning it, these bearings, of course, have been lubricated by this as it's turning. So that shaft is delivering power. And of course you just channel the ends. Just exaggerate it a bit. And that becomes a little reservoir, so you could do several of those also along the body of the plastic. And it lasts forever because the dynamics of it is this little deal here. Right, now that point there, let's go straight across. See how slow the computer's running? It's painful. That's what they do to try and stop us, you see. So we do a 180 all the time. What we're going to do is take this across the other side, if it cooperates. That lines up with that one. The other ones, however, can rotate. So let's take a slice of this. We're going to take it over to the other side. So we copy it, paste it. And we're going to grab it. Right, so we're going to there somewhere. That's the target. All right. Now, we select it. We copy it.
wait for it to line up. Paste it again. Now we got two of them. Take it to here. We line up that there. You highlight it. This becomes the fulcrum point of the circular point. And you'll notice when we move the bearing, we can tighten it up. Any point. These are 8 mils. Now, where we use that, so you get bearings for free. That's the point. We're using that there. These are magnetic gears. That's the North Pole, South Pole, North Pole, South Pole. So if that's the north, that's the south. North, south. So as this goes past in that direction, it is turning that magnetically so you can put the power on or off by bringing that up, down or back. And that's an alternator. Now at that point there, where all this interaction is taking place, these are bouncing back and forwards and all sorts of stuff's going on. What happens is you've got a gigantic scramble of EMF that you can put coils on top of that, and you can tap that energy. All right. In turn, you put that energy back in, because that's waste, you put the energy back into firing magnetic coils to push these around. So you got free energy, compounding free energy. But the most spectacular thing is what I was saying before, is you've got these, I'll just borrow them from here, are coming around, and they are exactly the shape and precision magnets. They're the magnets that are ferrite. So you have to imagine at this point, these are two magnets, one after the other. Well, let's just draw it for us. What are you going to say? Okay, that's a ferrite. Now, that's a ferrite, exactly square, 10 mil deep, or whatever you want, perfectly cut. And that one is the very, very hard, tremendously powerful neodymiums. You get them up to 60 now, strength. It's huge, very dangerous. Put them together, and they, of course, form a bar magnet, and they roll and slide along. Now, this is compressing the air in here. So as the air is being compressed, you've got to have a little line coming out of it, with a little tiny hole, coming up like that. And from that point onwards, as this is moving along, there's all these little saw teeth all along here, which this is giving this high pressure air into that. And there's a secondary one. This is extremely fine, right? So imagine these little things have got a cavity for the air to hit. So what's it going to do? Let's draw a cavity to give you some idea. You might have a sawtooth, something like that. Now this you can do in a laser, you draw it in, you go bingo, and she's cut. That's how easy it is. You don't have to use it. But that's what I will put into the bigger one. And this hole here, there, would be drilled in, because this, when we go to the bigger ones, will be 25 mils thick, or whatever the thickness of the material we can get. You've got to be able to see it working. So we'll drill down through here with a long drill, and then that will fill these cavities all the way around as it hits it. So you end up with a cavity like that. Then another one goes off the other direction. So you select it, copy it, paste it, and then you're going to build yourself a series of little holes that is exactly the same as the volume of air that's going to be pushed out by the. And when you get to a situation like this, good night, love. The situation like this hole, you bring that down. That's your fulcrum boss. You bring it down like that. And you got yourself a couple of teeth that this super high pressure air we're coming out of. Now this, if you was going to do it with this particular type of machine, you probably have to build it out of stainless steel or something to give it to be able to drill in there with a laser. And there's a possibility when you drill the laser, you can come in from different angles. So you go through it at 45, and you go through it another 45. So you do all sorts of magic. There's a stone in Egypt that no one talks about, and it was actually on watching it last night. It was Nasser Harriman talking about the wonder how many views King Harry's Happy Birthday got. I love it. And the Mad of the Hatter Award goes to... I didn't even say it right.